Testing. Hello.
Hi.
Good morning. How are you? Excellent. Good morning. How are you?
Pretty good.
You gotta remind me I'm in Sweden here. Shh. So, yeah. Anyway, welcome. Thank you for coming. It's great to have you all here. We've done I don't know if you know, we've been doing a JetBrains tour around Sweden. We love Sweden. Don't we love Sweden? We love Sweden. Even the south of Sweden. So we did Stockholm, and then we did Örebro with linking to Linköping or somewhere like that, and Gothenburg, and then we decided to do a little bit of a bigger day here in Malmö because we love Malmö.
Yeah.
How many of you from Malmö? Okay. Wait, let me rephrase that. I love Stockholm. I love Copenhagen. Anyway, so yeah. And so I know some of you have actually come from very far away. Very far away. I think there's someone from Australia, although he was actually living in London at the time, so it doesn't really count. So I hope that you're going to have an interesting day. We've got a lot of things to show you. We're going to make a couple of announcements, so it'll be fun. And we wanted to do this kind of thing first in a smaller group, so it's more comfortable. So just the agenda. There's two rooms basically. There's this room and the not this room, which is the other room. There's a little FooCafé banner outside the other room, but if you go outside here, turn right and then turn right again, you'll see the other room. This is the agenda. The other room is more or less focused on mobile tracks. We've got Objective-C, we've got our language, Kotlin, Android Studio, Windows Phone, and RubyMine, RubyMotion. And in this room, we're going to do some stuff with ReSharper and some UTrack, TeamCity, and history of IntelliJ when it went from Renamer all the way up to IntelliJ over a decade. Okay? So, after that, there's 15-minute coffee breaks in between sessions, so you can get all pumped up every time. Sessions are 1 hour. From 12:30 to 1:30, there's lunch. We close, the day finishes at 5 o'clock, after which there's going to be beer and wine, and anyone that does not drink alcohol. Okay, there's going to be Coke as well. There's water as well. And then that goes on until around 6:15, after which I recommend highly 2 locations. One of them is the Green Lion, the other one is the Bishop Arms. And if you like whiskey, you definitely need to come to one of those, which I do, which I'll be there. So around 6 o'clock you won't see me anymore. I'll be in the Bishop Arms. Wi-Fi is Media Evolution or Media Evolution City 2. That's the key. Media EV, is that an E in there? Yeah, EV4TW, and the hashtag, if you're going to tweet, is JBDay, okay? I want to thank our partners, Ediment, FooCafé, and Treton37 for helping us put this day together. And before I forget, one other thing, as a token of appreciation to everyone that's come here, we would like to, well, we've given you all a t-shirt. No. Did you all get your t-shirts?
Yeah.
Okay, good. We're also going to give you a free license of any tool of your choice, okay? So we will follow up with you next week, and we'll send you an email to a form where you can fill out the license details, what you want, etc. Okay, so you all get that. And with that, I'm going to give way to Oleg, our co-CEO of JetBrains. So Oleg, please come on.
I'm online. Okay, so as Hadi said, I'm co-CEO of JetBrains. We actually have 2 CEOs in the company. We're software developers. We know about redundancy, right? And I'm very excited to see so many people who came today to our first full day event about JetBrains product, to learn about what we have, what we're going to do, share some feedback with us. We always like feedback. And today I'm going to tell you about a couple things I love about JetBrains, a couple things that make me happy working for this company. And I've been with JetBrains since 10 years, and it's actually not much less than the age of the company. The company was founded 13 years ago by 3 engineers in Prague. And what's interesting about JetBrains is that however we've grown much bigger in these 13 years, we're now more than 350 people, we still keep to the same principles that were laid down in the very beginning. So one of them is, being open, and JetBrains from the very beginning had this thing called early access program, where everybody could get access to pre-release versions of our new software, right? Absolutely for free. We just wanted your feedback, wanted to know what you think about things we are working on to somehow correct our trajectory. And this program is still here with us 30 years later. We give the pre-release versions of software for free. And we're open as well in terms of showing how we work on these things. So, we have issue tracker, we have issue tracker, but our issue tracker is open to everybody. So almost all the issues that's inside the actual system developers is working on every day are visible to everybody. You can see what issues are planned for which version and how we progress on them, what gets assigned to who, and see the actual comments that developers leave to each other. We're open in terms of source code. The main asset of the company now in terms of code is the platform that we use to build our smart IDEs, the IntelliJ platform. And most of its code is open source now. It's under Apache 2, it's on GitHub, and you can use it to create your smart tools. That's what Google does now with the new Android Studio IDE. And we're open in terms of helping other people build open software, right? So we have this open source license program, and more than 5,000 qualified open source projects receive our licenses for free. The second thing I love about JetBrains is the goal that unites the company. The goal is to make developers happier. That's what everybody thinks about. And this can be displayed in everyday situations. Like imagine going up to a team that's been busy for 6 months working on a new product, building some platform, and you come up to them and say, guys, I have a thought now that probably what you're doing is not the best way to help developers, right? I have a new idea that maybe we should pivot here and change the way we do that. And basically it means for them that half of the work for the last 6 months need to be rewritten totally. And in this situation, normally it's very, very, very easy to get into very defensive argument, right? But that's not what happens. What happens is that people listen to you and they try to understand what you mean, and is it really the better way to help developers? And if it is, they try to be constructive. They try to think, okay, how do we reuse what we've done? How do we pivot better? And that's awesome. And next thing is that, well, what can be better than to work for a very successful company full of talented engineers, busy creating, I don't know, world's best search engine or geoinformation system. I think that the best thing is to work for a company full of talented engineers where everybody works to make tools for software developers. Because what that means is that everybody, not just software engineers, not just QA engineers, but also evangelists, marketing managers, CEOs, everybody talks about software development, and pretty much everybody codes. Myself and my colleague Max Shafirov do write code regularly, and I'll be showing later a project I've been working on recently. And what fascinates me is that with these pillars, the company can be very successful. JetBrains is very successful. And since our goal is to make developers happy, right? Our measure of success is how many developers we help already. And we measure that more or less carefully. And I'm happy to say that our estimates now show that more than 1 million developers in the world are regularly using our software. And I think it's great. And actually, it's not just success in terms of developers. We also are successful as a business. If you look at our customer list, you'll notice more than 64,000 business names for our loyal customers, and many of them are from Fortune 500 lists and things like that. So we have the resources to build upon to create new fascinating tools, and it's growing. So the business is growing at a rate of about 40% a month, and it's a rare result. You know, when you talk to business people, when they learn that you can create a successful tool business without venture capitalists, and JetBrains is purely privately funded, it's self-funded, so we can make our own decisions. We don't need to report to some finance guys. And this lets us have a unique approach to what we do. How do we create features? How do we create new products? How do we come up with ideas? And one of the best principles here we have is invention by necessity. So that's the way we created IntelliJ IDEA, because 3 engineers wanted a better software for themselves, a better tool that would help them get rid of the mechanical work they've been doing so much. The same principle applied when we needed a .NET profiler to profile Sharp itself. The same principle applied when we needed a better continuous integration tool that could cope with the number of commits we had. And so we created TeamCity, which is now making more than 3,500 builds every day with an army of distributed 150 agents, right? And it's a very powerful tool. The same principle applied when we needed a faster and more developer-friendly issue tracker. And so we created UTrack that now hosts more than 500,000 issues and handles more than 55,000 users, as the tracker is open to all of our customers, right? And it's very, very developer-friendly. You know, we have this command line, we have these shortcuts, we will have a DSL, a special language to program our custom workflows. And one thing we don't have is these nice reports with graphs that managers love, because we don't use them internally very much. Well, we heard that, you know, some companies need that, so we are actually working on that. It will appear, but not yet. So, invention by necessity, right? And let me pass the word to the Arzenkov, development lead at .NET. He will tell you about some research projects that got created out of necessity.
Yeah. Hello, everyone. So, I'm Ilya Arzenkov, and I'm .NET division lead in JetBrains. I've been working for JetBrains for about 7 years. As Oleg said already, we are inventing things by necessity, and that actually means that we are a pragmatic company, that we are doing tools that are very much useful, and they are like not something scientific and very much for like big guys and that know everything about lambda calculus and all the stuff, but for the people that do software. And one of the very important things in our tools is this is invention by necessity, and the pragmatic things is that this principle bakes almost all our decisions that we make while building our tools and our stuff. So one of the most important things in software development, you know what it is, right? It's source code. It's text files. Text files that you do, that you edit, that you read, text files that you put into your version control, that you hand to the other tools like continuous integration and all the stuff. In order to make computer understand your text files, you have to have the compilers and all the computer languages, right? So while building our tools like ReSharper and IDs and all the things, we are usually sticking to the pragmatic languages, right? That things that every developer is used. For example, we don't have an IDE support for Haskell or something like that. It's a little bit of scientific stuff. And since we are doing language and framework support for more than 10 years, we actually observed what's happening with languages for this decade. And languages, they evolve, they change. there are new languages coming, and the existing languages, they are starting to have more features, or starting to have many things there. So the evolution of languages mostly going through the DSLs. This could be a little bit of a controversial topic because DSLs is so wide term. If you think about it, you are using DSLs all the time. It's like if you code in C# and you're using a for each constructor, using statement or log statement. It's all DSLs. It's just DSL for threading or collection manipulation, or if you take a link queue or something like that. It's mostly the domain-specific language for some things that you usually do. Since C# compiler 2.0, it didn't change a lot if you don't take the syntactic sugar. Like you have all these yield statements, and you have auto properties, and you have many new constructs, but they are mostly the transformations of the code. And this means that currently we are relying on the compiler vendor on the syntactic sugar that we want to use, and we cannot build just the DSL that we want, just when we want it. Once on the conference, some guy was showing the session about the DSLs, and he had like 10 minutes introduction about the DSL, what it is and why do you need that, and then he had like a 50 minutes explaining how to write a parser, because you have to make sense out of your text, out of your DSLs. And at JetBrains, we have trying different approaches to improve this thing, because your compiler is your like core tool. Refactoring is nice, but if you can't compile your code and can't read the text and can't understand it, it's not very good. So the first approach was MPS system, method programming system, that means that you design the language first and then you write your program in your language. But there were some issues with this concept, because it's not text. It stores the syntax tree in the system, and then you have a limited ability to use your favorite tools like version controls and continuous integration and formatting and all the stuff like that. So currently we are moving into two simultaneous directions, trying to make it easier to make not just libraries and frameworks and write DSLs like a fluent syntax that we are currently usually doing, like having a framework and vocabulary and doing it like this, or using lambdas and expression trees to pass some information, and using other hacks, because we cannot change the language without Microsoft, right? For example, for C#, we cannot change the Java. So the first one thing that we are doing is the Kotlin language, the language for JVM, and it's like a better Java, but it's not Java. Actually, it's much more powerful thing, because it has this syntactic construct that allows you to build the real DSL that you can comprehend and can understand and read like a domain-specific program. For example, we are using Kotlin right now for production, for internal tools, and you can have a DSL for HTML, for CSS, and soon for JavaScript and all the things in a single titled language. And there will be a session on the Kotlin, so if you are interested in this kind of thing, you can visit and listen about it. But there is one important thing about Kotlin, it's the solid language. So you cannot change the language itself. There are powerful features for building DSL, for building expressiveness in your text files, but then the language itself is self-contained, it's solid, and it's the language like usual language. There is another concept that we are trying right now, and it is in the research phase. And that is what I want to announce that is not very much known today. It's the technology that we call Nitra. So the Nitra is a language workbench. So it's a system where you can build your languages easily. You don't need to read the Dragon book from like in its entirety, and you don't need to understand a lot of things like shift reduce conflicts and build the parser and all the stuff. So it's in early stage. We just have the parsing technology, but the very important part of this, there are two things. First thing is that it's extensible. So if you develop a language in this system, you can add to this language from the side. For example, if you implement a C# language in the Nitra technology, and we already have a parsing for C# 5.0 and all this stuff is working. So you can add your syntactic construct to the C# language and use it. Or you can design your own language for things that you see is good. So let me show you a little bit of example that we can do with things like that. So, okay. So this is Visual Studio. We are trying to integrate all the things. I'm sorry. I forgot to say about the second thing. The second thing is integration with the tools. So if you write a language, and if you write a compiler, develop the stuff, then you usually dependent on the tool makers like JetBrains, for example, to support the find usages and rename refactoring and syntax highlighting and all this stuff. With the Nitra technology, we are going to have it like for free. The basic support for the language, like IntelliSense and all the stuff, except for complex analysis, you're getting free. So, how many of you have seen this kind of stuff? So this is DSL. So this is XML, and it actually it's real thing from ReSharper source code. It's analysis definition. What's going on here? So you can see that this is the group of redundancy analysis, which is a lot of things. This is a large file. So if you scroll down, it's large. It's big XML file with parts of code in here. We hand it to the tool. This tool reads the XML file and converts it to the generated C# code. But the problem is that it is hard to understand what's here. It's hard to modify this thing. It's really hard to make tooling for this, because if you rename something like quick fix name, it doesn't get renamed in XML because it's not bound to a type or something like that. So it would be nice if we could make something better than that, and we actually can. Hello? Okay. So this is what we want to achieve. So this is the DSL for code analysis. It looks like a familiar construct, like nested things, like a group of code redundancy, and then there is a description of an issue about the redundant past, and then there are some options like title and description and severity, and there is some code. And this is like a little bit like Razor, so you can put a C# code here actually, and it will be interpreted as a C# code. So then we need to process this thing. And right now we have in place a working parsing technology. And how would you describe the language? So you don't need to write a lot of DSL. It's more like, BNF thingy. It's more like a syntax by example. So you have this syntax file here, and you say that the file is just a using block and the number of groups, and the using block is the number of using directives, and the using directives is the using keyword, a qualified name, which is namespace, and things like that. So this is all. So this is the whole description of the language. You can easily write your own languages like in a couple of minutes, and then you can generate the parser, and it will automatically generate the formatter. It will generate the things like code outlining. Like you see, we bootstrap this stuff. So the Nitra is written in Nitra, So this syntax is written in Nitra. The code that processes this syntax is written in Nitra as well. So you can see the syntax highlighting the ls strings and the syntax in the ls keywords. You can see that there are outlining thingies working here, so you can have all the IDs thingy. It's still early stage. It's not all services are ready, but we're working on that. So, and then, let's see, there is like a usual example of building a calculator, which is also very easy, and it shows another thing that is important, that you can have calculations on the syntactic tree. So this is actually a working calculator. That is the whole program that make it working. So you define operations, I'm sorry, and this kind of stuff. So right now we are getting ready for EAP program. This is Twitter header, right? So we are going to post EAP program for just parsing technology. And then there is a bigger goal, a goal that you can make a compiler out of that. So that will be working side by side with all your languages that you are using in your code. So it looks like this. You have a C# project, for example, right? And all you do is change the compiler. And now the Nitra will compile your C# code. And it works good, and then you make a new syntax sugar that you were asking Microsoft to make for years. And then it just works there. And then you have a DSL like I just showed that, and it gets compiled into the same assembly, and DSL languages are getting mixed into the same program. It's all the same program, but you have different languages there. So this is mostly all about the Nitra. So we are going to have an EAP program, like I hope this month. There are a couple of bugs that we need to fix, mostly performance issues. And now I will probably ask Oleg to continue with the things that we are going to make available really soon. Thank you.
Do you hear me? Right. So invention by necessity. And well, so when at JetBrains we need some tool, we can easily create it ourselves. We have ID, right? We have issue tracker, continuous integration system, we have even our own programming language. Actually, we even have our own database, which is used by UTrack, but we don't commit is only visible to John, it's his own commit, and we don't show it to anybody else. It doesn't get synchronized to their local repositories, unless you say that you want to make it visible to people. And in this case, they can look at it, they can give comments, etc., etc. And there is also an operation of publishing that's different from sharing, where I make my private commit a public one, and then it goes to the public branch, and everybody can build upon that. Right? So the second concept that we wanted to achieve with this continuous version control is that the working state, actually the changes that I made on my local machine but didn't commit yet, we also want to have them in the repository, because I want to make sure they're backed up. I want to make sure that I can start working on one machine and then continue working on another machine, or from the web, or share my working state, which I cannot commit because it's partially broken, it's not complete. I want to share the state with my colleague. We want to work together on it, right? So to do that, we add these working copies to the repository as well, and we have this background process that scans your files, and whenever you change a file, we upload this change to the repository, and we go to the central repository as well. And the great thing about that is that you can have multiple working copies. So you can start work, okay, I'm in the middle of fixing some bug, or in the middle of a bigger factoring, I'm not complete, I cannot commit that. I don't even want to make a private commit because it doesn't make sense what's there in my files. And then some colleague asks me to fix some bugs. So what do? I just can create another working state, a fresh one, switch there, work there, and then get back to my refactoring. And that's all is handled with version control. And that's all the states are available on every machine. And another great thing is that the conflicts are also part of this working state, or this working copy. So if I try to merge two branches and there's, I don't know, 1,000 conflicts, and I resolved 500 of them, and then to resolve the rest I need help of my colleague. So what happens in Git or Subversion? Just locked, because you cannot save this state and start working on something productive. You have to make another clone of the repository or something like that. In our system, you just create another working copy, switch there, and continue your work. And this working copy, when you did the merge, remains there in the repository. It's in completing state. You can get back to it when your colleague comes back to the office, and you can sit with him, or you can actually share this working state with your colleague and ask him to perform the merges in his code. And it has a number of other great things. So it has synchronization with Git. So you don't have to make the transition from Git or Subversion or some other system entirely in one step to our solution. So the way you do that, you actually set up, you, for example, have a Git repository right already in the team, and then you set up our system and import your Git repository and say that you should synchronize our repository with the Git repository. And whenever you make commit in our system, it appears in Git, and whenever you make a commit in Git, it appears in our system. So you can start working and having these advantages of multiple working copies and things like that, while the rest of the team works in Git. And when you can see how productive you become, they actually can also install our system and gradually switch over. And we have this great concept of sub-repositories. So basically, how it works with Git is that you associate the root of your version control with a remote repository. And you can do that with any directory. You can say, okay, the entire repository is in Jink, is in our system. Well, Jink is code name, it's not official, so, but I sometimes use it automatically. The entire repository is in our system, but this directory is in this remote Git repository. For example, a library is there, or a project I depend on, right? And the synchronization happens automatically. There's no these module files and things like that. Whenever a commit appears in this remote repository, it appears in your system. And in this way, you can stack multiple Git repositories or multiple repositories in our style. Now let me show you a quick demo how it looks like. So, so the advantage that we have with running this local process that's constantly in the memory, so it synchronizes your repositories, it looks for the changes on your local system, and it also provides you a bundled user interface. So you don't only get this command line thing, but you also get a nice web user interface bundled with the system. And that's how it looks like. It's very raw, so only the Jink team use that now. So here we have the list of repositories that we have locally. You can click on one and see, okay, here we have the branches, and here we have my working copies. So I have now one working copy. I can click on that. So here are my uncommitted changes. And below is the history of the changes I have here. So here are the commits that are parents of my current state. And that's infinity scroll. I can scroll it and scroll it and scroll it. And actually I can see what's happening there. So I can click on the commit right. This resolution doesn't look very nice. And here you have all the changes. So it's normal repository browser. And the same I can do with my uncommitted changes. So I can click on the file and see what changes are there but not committed. And here I have this update button. So there are some commits in the public branch which are not yet in my working state. And at any time I can see what is incoming, click update, and then I get rebased to the head of the branch. So let's see what I did here. So I have the central web server.java file, and there are some changes in the logic. So, and if I switch to IDEA here, see, the resolution is so much different. The return display is so nice. So here I see that I have these changes in place. And imagine that actually this is actually part of bigger refactoring, and I just cannot commit them now, I cannot share that. So, but I need to fix some bug, maybe actually in the same area. So what I can do with our system, I go to the list of working copies, and say work on this resolution. Yes, so the button wasn't visible. I say it's a very early version. Only one team at JetBrains is using it now. We hope to gradually expand it to other teams and then open early access program. And by the way, the layout now is only works in Chrome. You know this, yeah, because browser issues. So, but I can click this button and create a new working copy. And what's interesting that this new working copy doesn't contain my changes, but it's on the head of the branch. So these 4 commits that I didn't have here, so here it ends on Jink 474 fixed, and here I have Jink 474 fixed, and these 4 commits that are on the public branch. So I'm here fresh, and then I can check it out, so I can make it current copy on my disk, and when I switch here, and project. Yes, here we are. When I open the central repository server, I see that my changes here are actually undone. So it's the state that there's current on the public branch, and I can do another refactoring. So I can, for example, extract a method here, say, so this is get pass context. Here you go. And then, if I get back to the system, I see that, okay, here this change in central web server Java. This XML change is automatically made by IDEA because it substitutes some path variables. But here the change in the central web server, that's actually the extraction of the method, right? And it's only this context, so I can actually now say that I extracted context, and I can say okay, this resolution doesn't work very well, but anyway, since I'm using this thing every day, trust me that on Retina I can commit and then the commit appears here, but it's not public, and I can make it available, make it public with the click of this button. And when I'm finished, I can actually go back here to working copies. UI requires certain skills, right? You know that? Let's go. Alright, so I can switch back to my previous working copy, and then I can check it out, and then if I switch back to my IDE, so everything is back in my previous context, and I continue working on it. Okay, that's it. That's our system. When we have news, we'll make it public, we'll publish it on blog, on Twitter, so stay tuned in. And the last thing I wanted to talk about is the way we can make our main asset, the intelligence about source code available on the web as well. So version control is great, but what about the navigation things? What about the analysis that I'm used to in my desktop environment? And we have an answer here. So we have this system as platform called Upsource that we made partially public in May. And let me quickly go through some of the updates that we have in the system now. So Upsource is the online platform to browse your source code. And with the fresh release that was made available just last week, we now have 2 projects by JetBrains hosted there, and it's available publicly, so it's upsource.jetbrains.com, anybody can go there and see. And we have a number of popular libraries available there as well. So now we added full source code of Android SDK. So if you had issues, browsing and finding things in the Android SDK web programming applications, you can go to Upsource and see that. So when you open the library, you just can browse the code as usual. So there's file structure, you can open a file, right? And we have all the highlightings, and we have all the navigation, so you can click on things and see documentation. And you can go to declaration, find usages. And there is also this analysis marker. So we perform the analysis here. You can see that some deprecated items are used here, for example. Or instead of browsing files, you can just use GoTo symbol here. So we have location, and you can go there. You have all the navigation. You can see, okay, it remains parsable. What is it? Go to declaration. Very easy. And you can also find usages. So if you want to see how a library class is used, you go to find usages and see, okay, here we have a GPS location provider. Okay, it's interesting. What is it? Okay, it actually implements some location provider interface, and you can see what other interfaces, so what are the possibilities to get location service. There's GPS, MOC, some passive and proxy. So the entire thing. And with projects, you get even more. So if you take, for example, IntelliJ Community Edition, you not only get the fresh sources, you also get the entire history. So you can see different commits, you can expand one, and you see changes, you can expand changes, and you see this inline div very easily. If you want more information, you can switch to two-pane div, and we have this navigation and highlights which is synchronized between two panes, and you can actually have our navigation features in every revision, even back in time. So here, if I click here and say go to declaration, declaration event back in that revision. You see that revision here, so you can analyze the code, how it was like a month ago. And the same history perspective you get when you work with any file. So when you open a file, you click history here, and you can browse it easily and see what happened before. So you can see previous changes, and you can go there. So now it's another revision, and you can of course go to any symbol. So you can say PSI Manager impl, for example, and browse everything. And the best part is it's not only just deadly hands-on line there, you can actually work on that with your friends. For example, if you open a code and then you have some code you don't understand, so like it's project default, what the hell does it mean? You can select it and say, okay, copy link to this part. You copy link, and then you have your friend who was working on this code in your chat, and is familiar with this library, and you can send him the link and say, hey, I have a problem, I have a question about this part of code. You don't need to explain where is it. Just send him a link, and he opens that, right, and everything is selected. So it's very useful for communication. Now, Upsource is not a product now, so it's only available as hosted on our site, but you can think about many actual products that we can base on this platform, this JetBrains platform of the future. And now, let me pass the word to Dmitry Zhemev, CTO of JetBrains, who will talk more about our platform of the present.
So, hello everyone, so my name is Dmitry Zhemev, and I'm going to talk a little bit about what's happening on the Java side of the company. So, yeah, you've heard a lot of new and exciting stuff during the past 40 minutes, and today I'm going to focus a little bit more on what's already out there, but I also have some new things to show that we didn't previously show to anyone else. So what's the Java side? Java side is our line of IDEs. So right now we have 6 of them that are already in production. So IntelliJ IDEA for Java, PHP Storm, WebStorm for JavaScript, and web development, PyCharm for Python, RubyMine for Ruby, and AppCode for Objective-C development. And as a business, this is actually doing very well. So actually JetBrains, the business of JetBrains does not actually grow by 40% a month, as Oleg said. That would be nice to have, but it actually grows by 40% each year. And the growth of the IntelliJ platform-based IDEs comprised 50% in the past year, so between 2011 and 2012. And looks like we are on track to get the same level of growth this month as well. So the sales for this part of the year, from the beginning of the year until today, are roughly the same as the sales for the entire previous year. That's not the only exciting things happening with our IDEs. Oleg also mentioned the announcement of Android Studio at Google I/O. So Google is actually using IntelliJ IDEA as the platform to build official development tools for Android going forward. And Android Studio has been very well received by the community. So during the first months after the announcement at Google I/O, Android Studio was downloaded more than 500,000 times. And another interesting and very little known fact that our collaboration with Google is entirely governed by the terms of the Apache 2 license. So we did not sign any additional contracts, we did not pay any money to Google, or Google did not pay any money to us. It's just all open source, all governed by the license. I think it's a very cool success story of just open source license terms. So So what else is there in the Java world? There is also Kotlin, which Ilya has already mentioned. And speaking of Kotlin, well, it's been around for a while, and the team has been very actively working on making this better and making this good enough for us to actually start using it full-time for most of our development. So the first thing that the team has been focusing on very recently is compiler performance. And obviously making a compiler faster is not just a matter of optimizing some tight inner loops. It actually takes some work to refactor the code base to put it into the right structure so that the processing is efficient. So this work takes time. So, but it's the highest priority for the team, so we are going to have some very nice results very soon. We work on making small refinements to the language, so we are quite happy with the overall design, but we constantly come up with ideas for things that can be done better. For example, we have implemented SAM conversion recently so that Kotlin's closures can be used in the same, be used for interoperating with single abstract method interfaces in Java, just like Java 8 closures. We have implemented a cool concept called delegated properties, essentially allowing the class implementer to provide custom implementations for properties. I won't go into details, never mind. So it's like small incremental changes to make the language more efficient and more usable. The third thing is obviously the IDE features, so we want to provide first-class Kotlin development experience to everyone and to match the level of development productivity that we have for Java, and so we are implementing all the refactorings that we have, all the code inside features that we have. There's a lot of work to do, but we are working on it. And finally, I'd like to mention Kara. Kara is a web framework for Kotlin that was not actually started at JetBrains. It was started by a small company in the UK. But we have embraced the project and we are contributing very actively to it, and we are using it internally for some projects already. And actually one of those projects has gone into production at JetBrains very recently, completely built with Kotlin and Kara and all of this technology stack. So I hope that, so all of this work is available right now, and we hope that we will start introducing Kotlin into our own projects, like our IntelliJ platform-based projects very, very soon. And finally, I want to talk a little bit about the C++ IDE, which is something that we have announced, but we did not really say much about this until this point. So actually we have two different development environments for C++ that we are working on right now. So the first one is based on ReSharper. This is like another side of the company. This is not what I'm going to show, but we did some demos of it at JetBrains Day in June. So it's an extension of ReSharper, which means that it's Windows-based. It works only on the Visual Studio, and it works with the Microsoft toolchain, the compiler, and make and project system and stuff. And it supports the Microsoft extensions to the language for Windows runtime development. And the second development environment is what I'm going to show you right now. It's the one based on IntelliJ platform. So we already have an IDE for Objective-C development, which is called AppCode, which has a lot of C++ support built in. But AppCode was Mac-specific, and it only supported Xcode as a project file, and obviously this is not good enough as a general C++ IDE. So now we are making this more extensible. The new IDE is going to be cross-platform. So for now it uses CMake as the project format, and we are obviously going to support other systems as well. And right now it's primarily focused on the GNU toolchain. So on Windows it uses MinGW, and on Linux it just uses the GNU compiler. And well, going forward, what we are going to support is going to depend on your feedback. So once we open the EEP, please come to us and tell us what you need and what kind of project you are working on and what you would like to see supported. So now let me try to show some demo. So this is very early and very new. So you see that the project does not really have a name, does not really have an icon, but it's just some piece of code that works. So before you start working with it, you need to point it to your installation, to your tool chain, so the CMake installation, the MinGW installation. So you just need to have them installed. Once you have that, you can open your project. And as the project file, we use the CMake, the CMake list of txt file from CMake, which tells you the name of the project and the files that the project is comprised of. So now if you switch to a file, you see that a lot of stuff, so we have quite a lot of language support features already running. For example, we have inspections running here, so control wishes and a non-void function. Is there a quick fix? Yes, there is a quick fix for that. Unused function. Function is never used. Quick fix, save delete. Save delete refactoring. It works. We also, unused import statement, or rather unused include statement in this case. It all works. If you switch to a class file, you see that all the methods here lack implementations, and it's very easy for us to, also there is a quick fix to implement them. So just press Alt-Enter, implement constructor, we jump to the CPP file immediately and we get the implementation there. We can actually, to generate the rest of the methods, we can use the implement methods action, just go through them, they are all there. Return, let's return a new bar. Code completion works obviously. Or for example, we can call, let's go here and say get bar, there's a XCC method over there. Now that we have that code, we can actually use the introduce variable refactoring to put this into a variable. Extract variable, pbar. You see that the name looks reasonable, just the reasonable amount of intelligence works. The rename refactoring works as well, so we can rename this method to, I don't know. It has been renamed, we can just go to the implementation to make sure that the rename actually happened. So you see there is a fair amount of code inside features already working. So why is it not available yet? The reason why it's not available is that there is a lot of stuff that is currently missing. For example, right now there is actually no way to compile and run your project, which is obviously quite an important stuff, things for an IDE to do. And this is all in active development, so we have ramped up the team work on that very recently, so we have like new people who started like in August and starting in September. And we hope that we are going to bring this like into like reasonable, decent shape by the end of this year and start an EEP program for that. Please stay tuned and we will announce it once it's ready. If you're interested in learning more about how the IntelliJ code base evolved, how we have reached all this wonderful state that we have now, please come to my talk. It's going to be the last session of the day at 4 p.m. in this room. And thanks everyone.